Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 108 called the Convert Sorted Array to Binary Search Tree. And for this particular challenge, given an array of nums where the elements are sorted in ascending order, convert it into a height balance binary search tree. What it means by the height balance binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than 1. And for this example 1 right here, we have the root node which is 0 and the left property that takes the left property of the -3 node, and then the right property which is the 9 node, and also the left part on the left subtree has the -10, and the left part of the right subtree has the value of 5. And it is considered the height balance tree is because we have the root node which is the 0 right here, which the root node, and the height balance, we have the length of the right property, we have the length of 1, and then goes down again with the depth of 1, and also the same thing with the left side, we have the depth of 1 and also the another depth of 1, and from the left and right respectively we have the height of 2 and 2 respectively. So that is what it means by the height balance. No matter which part you insert after the -3 right here, let's take an example for the -3 node right here, and we have -3 in the left part of the main root tree. That no matters if you want to insert it onto the left property, which is left, or the L, and or the right property, which is the R. You put -10 on left or right, it doesn't matter. What only matters is you only have the depth of 1, and also on the right side of the node, it doesn't matter if you insert the 5 value right here on the left side of the subtree 9 or the right side of the subtree 9. So that is the height balance binary search tree node. And it's also the principle also applies on the same thing on the different situation right here, which is the main root is also the 0, and also the left side or the left property is -10, and also the right property of the left subtree has the value of -3, and also on the right property has the value of 5, and then the right property of the right subtree has the value of 9. So that is still considered as the height balance tree. And for this example 2 right here, no matter if you want to put 3 first or 1 first into our node root and chain it using the another node, which is, for example, either 3 or 1, it doesn't matter, it's always returning as the depth of 1, no matter the order. And the next thing, we need to solve this out. We are using the TypeScript as our language. If you want to use something else other than TypeScript, then go ahead, and encourage you to do so. And for this function right here, we have the sorted array to BST, which is the binary search tree that takes only one parameter, which is nums, in the form of array of numbers or array of integers, and the expected output is in the form of either TreeNode or null. A TreeNode custom class is defined by the commented class right here, which is the class TreeNode, and has the value of the number and the left property of the TreeNode, which is left part of the -3, and this is the -3 as the left part or the left property of the 0, and 0 itself is the value, and the right property, which is the 9 right here. And for the constructor, we can create a constructor by using a new TreeNode that takes either 1 up to 3 parameters using the first parameter, which is the value itself, and the left property, which is the either TreeNode or null, and then the right defined by the question mark if the right is inserted as the parameter or not. So it is up to us to define it. In order to solve this, we need the constructor, and we need a property assignment to the left and right to determine if the array we are transforming this array of numbers of the nums into our binary tree, height balance binary search tree. And then we have to declare some kind of helper function, but before that we need to consider about using the recursive, because we are working with array of numbers and the tree nodes or the binary tree. Then we need to use a recursive approach, and we are working from the back to the front. And the main thing about using the recursive is about calling the function itself in order to achieve another function call. So that is the main thing of using the recursive call. And without further ado, let's solve this out by creating something called the helper function. We need to declare a function called the tree constructor that takes the parameter, takes two parameters. It's because that we need to declare some kind of pointer to define the middle part, which is the nums array. Right here we have the middle part of 0, and 0 will be added as the root, as the main root of our array, and the 3 and 9 will apply it on the left and right respectively. So we need to read the array from the middle, and then as the array goes down, taking the left and right property is by calling the after the middle part is by using the takes another middle part to find between either 10 or -3 as the next left part, and then the 5 or 9 as the right part of the subtree. Then we need to determine the middle part between these two. Let's say, for example, we have the array length of 5, then there is no middle part after the 0, which is only 5 and 9. Then we need to somehow extract one of them, and we insert it as the right parameter of 0. And then the 3 and 10, since they can be swapped, if you want to use 10 first and then 3 later, then it's okay, as long as we insert 3 into our 3 or 10 into our left property. Then we insert either 3 or 10 inside the left property of the 0. And for the next one, since 3 already used, 0 already used, and also 5 already used, then we need to use the 10 as the left property and then 9 as the right property of the right subtree. And it is fairly okay if you want to use the left or right property when we are assigning the 9 into our subtree of the right part. So that is the main thing of using the binary search tree. If we happen to have, let's say, we have the array of 0, 1, 2, 3. Let me declare this 2, 3, and then 4, 5. Let's declare our middle part. We have 3 as our middle part. Let's declare more again, 7 and then 8. And we have 4 as our middle part. And then we automatically extract the number of the nums of the middle part of the middle index, and we extract 4 as our value of the root, and then we assign either 6 or 7 into our right subtree. And then for the left subtree, we can either assign the 2 and 1 into our left subtree. Why? Is because we already defined the middle part, then we need to extract from the range of the 0 from 0 to 3, and also on the right part we need to extract the middle part of from 5 to 8, since 5 to 8 has the value of 6 and 7 and it is an even number. Then we need to either pick 6 or 7 as our middle part. And the same thing also applies if we have 10 or have 11 elements into our nums array, and we extract 5 as our root, and then the next one we will extract 8, is because after we pick the right portion of the after the middle part, excluding the middle part, then we need to extract this right portion from 6 to 10, since the middle part from the 6 to 10, then it has 8. And also the same thing also applies on the left part, which is the left portion of the subtree. We have 0 until 4, and excluding the 5 because 5 already assigned as the root, then we need to count the from 0 to 4 that takes the middle index of the left portion of the array. Then we need to extract 2 as our left property of the node of 5. Okay, so that is really a tough explanation. Let us code instead by using the function called the tree constructor that takes 2 parameters. The first one, we need to define the life pointer. The life pointer, since we are working with the recursion, then we need to declare the function using the return and tree constructor that takes the index of 0, since we are starting from the index 0, and we need to define the middle part between the first index and the last index, which is the nums dot length and -1, because we are working with index. If we text the length right away, then the right pointer or the right index will points to the 11 instead of 10. So we need to use -1 because we are working with the array. An array needs 0 index. Then we need to subtract by 1 to point to the right last index. Okay, so for the function tree constructor right here, since the main function of the sorted array to BST, we have expected data of the TreeNode, either TreeNode or null, then we need to explicitly return either TreeNode or null. Since we are using the TypeScript as our language, then the expected return right here is already defined by the either TreeNode or null, then we need to return new TreeNode. So we are using this as our placeholder, and we have to declare since 0 as the left pointer, we need to declare 0 as the left pointer as the parameter, and we define the parameter of the colon sign. We need to use number, and then the right pointer, you guess it, right pointer, also in a form of number. Then we are returning another TreeNode since it is a placeholder. Then we need to declare our middle part called the constant mid pointer. We need to use the Math.floor, and floor the left pointer added by the right pointer, and then divided by 2. Then don't forget to wrap the left pointer and right pointer with the parentheses, because we need to count this first, and then after that we need to divide this by 2, and finally we need to Math.floor this. So what it means by this kind of expression, in order to find the mid pointer, we need to define from the 0 to 10, since left pointer is pointing to the 0 from the parameter here of the index. Then the last index is pointing to the last index, which is the nums.length -1, and we are pointing to the last index of the right pointer. And after that, we need to use 0 plus 10. We have 10, then divided by 2 is equals to 5. And Math.floor is not doing anything because it's already an exact integer of 5 without a floating number like 5.1, 5.2, 5.5. If it is a 5.5, then it will be floored by using the Math.floor right here. Then we return 5. If it is 5.5 or 6.5, it will return 6, or 7.5, it will return 7. And since 5 is pointing to the middle part right here, then we need to use the mid pointer as our new node. Then we need to create another new node called the new node. We need to construct a new node, new TreeNode. From the constructor right here, of the constructor value, we have the first parameter, which is allowing the value as the parameter, and we can pass in the mid pointer. How? We can use the nums from the nums parameter right here, since we are inside the helper function. Then we can declare the nums, and we point to the mid pointer using the mid pointer of the constant variable right here. Then we already declared 5 as our value inside of the root, and we already defined root constructed with the new TreeNode that takes no second and third parameter of the left and right, because it is allowing the class itself allowing us to declare either 0 or 0 and up until 3 parameters all at once by constructing this part. So we only need the value property for the constructor. Then we pass in the mid pointer, which is 5 right here, and we assign 5 as our root. We already created the new TreeNode, and we store it as the TreeNode variable. Then for the next one, since we are using the recursive, then we can return the new node as the new node from the variable, constant variable that we already defined right here by the constructor. But before that, we need to declare the new node dot left. We need to assign the left property of the -3 right here. We declare left equals to the, we are calling another tree constructor. We are calling the helper function itself, declare the tree constructor, and recurse through the function itself. And we have to pass the left portion of the array from the 0 to 4 by using the first thing is going to use we are going to use the left pointer, and the second parameter, which is the right pointer, we need to pass in. Since the 5 already assigned, then we need to text this portion, and the left pointer is pointing to the 0, and 0 is already passed by the left pointer right here. Then we need to declare the right pointer, which is the 4 value right here. Since 4 value is staying on the index 4, then we need to assign 4 as our index. How we are going to assign this? It's very easy. It's by using the mid pointer, and then -1. That we already defined the left parameter using the portion of the array as the pointer, so it can be constructed again by the helper function right here. And we define the mid pointer, and we create a new node which is on the left subtree, and creating another left property using the function itself of the helper function itself, and calling the left pointer and by middle pointer -1. And we can also use the same thing on the new node. You guess it, using the right property that takes the tree constructor. We don't have to worry about creating a new node because we already declare this after we declare the helper function. Since the new node constructor is inside the tree constructor helper function, that we need to assign the new node dot right. Just use the tree constructor instead of creating new tree node because it's already handled above. So that is why I am directing you to work from the bottom to the top instead of the usual flow that we already solved with the past challenges. So that is the main thing of using the recursive call or the recursion. And for the right property, we need to assign using the after the middle part, which is the 6 to 10. How do we do this? Let's define 6. Since 6 is placed after the middle part, since middle part is already taken, then we need to place 6 as our new left pointer is by passing the mid pointer +1, and then the second parameter will be the 10, which is the last index of the array, by using the right pointer. And that's about it. Yeah, and then we can return the new node from the already assigned new node dot left and new node dot left into our new node, and the new node will be automatically returned from the tree constructor, and it will also return by the last return statement of the tree constructor right here. So the sorted array to BST will return a tree node because from the helper function of the tree node right here, new tree node constructor. But before that, we need to do one more thing. We can add an edge case to check if the left pointer is already past the mid pointer. Let's say we already exhaust all of the portion of the array. Let's say we already used the 5, and then we already defined the 2 as the middle part of the left subtree. Then we need to declare selecting either 0 or 1. Then we process the tree constructor again of the left property. We only have 0, and then we assign 0 as our left subtree, and then the option already exhausted, and then we don't have any portion of the array. To prevent this from overflowing, then we need to declare a pointer edge case to check if the left pointer is already above the right pointer. If it is, then we need to return null instead of returning another TreeNode like already stated from the helper function right here. It's returning either TreeNode or null. So that is the edge case to handle the exhaustion, and we can run this code to see if it works. And looks like it's all passing. Let's run the code, submitting this code using the control and enter to see if it works. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.